going to derive what are called the law of cosines. The law of cosines allows you to find any part of any triangle. No longer does it need to be a right triangle. So I'm simply going to start here by drawing out a triangle. I'm going to label every part of the triangle, and let's call this angle A, angle B, and angle C. So if this is angle A, that means this is side A. Angle B means this is side B, and angle C means this is side C. Now we are going to use, it really doesn't matter, I'm going to use point C as my point of reference. Okay, so I am going to be basing the altitude that I draw and all my substitutions based on the fact that I'm looking at angle C right here. So I'm going to drop a perpendicular down here. I'm going to label that H for height. Okay, and now I'm going to split side B into two different pieces. Let's call them X and Y. Right, where B is the entire length and X is this portion and Y is that portion. Okay, so now I'm going to look at this triangle right here. I'm going to pull it out over here. So there's H, there is A, and we called this one Y, knowing that that's angle C. So H, let's find out what H is equal to. Let's find out what Y is equal to. So H is the opposite side, and A is my hypotenuse. So opposite and hypotenuse sounds like it deals with sine, right? So, ka, toa. So opposite and hypotenuse. The sine of C equals my opposite over my hypotenuse. In other words, H is A times the sine of C. And Y is my adjacent side. So the cosine of C equals my adjacent over my hypotenuse. In other words, Y is equal to A cosine of C. So I'm going to redraw my triangle here with my new labelings. I have A, I have B, I have C, I have A, I have C, I have a perpendicular, and X, well, the whole side was B, but now it's B less Y, so B minus Y, or B minus A cosine C. This is A cosine C, and this altitude right here is A sine C. Alright, so now I'm going to look at side C, and I'm going to use the Pythagorean theorem to look at side C. Notice what I have right here, since I dropped an altitude down. I have a right triangle here. Right, we had it labeled up here as a right triangle. So Pythagorean theorem says C squared equals A squared plus B squared. Let's expand these. So B minus A cosine C times B minus A cosine C gives me B squared minus 2AB cosine of C plus A squared cosine squared C. Write these out next to each other if you need to. In order to square a binomial, you should get that middle term. Plus, and this guy is not a binomial, it's a single term, so I do A sine C times A sine C, which is A squared sine squared C. Okay, so I have B squared minus 2AB cosine of C, and I notice I have a like term in A squared here, so I'm going to factor in A squared out. And I get cosine squared of C plus sine squared of C. Well, cosine squared plus sine squared, that better sound familiar to you. That's just a fancy form of writing 1. So I really have c squared, right? This whole thing's equal to c squared equals a squared plus b squared. Well, that's just Pythagorean theorem there. Minus 2ab cosine of c. And that, my friends, is the law of cosines. Now remember, I used angle C as a point of reference. This can be done for all three angles. In other words, if I used angle B as my point of reference, right here, angle B, I would have dropped my altitude this way, or I could have done that way. It really wouldn't matter. Okay, you drop an altitude a different way, and I'll then get, instead of A, B, and C like this, I would get B squared equals A squared plus C squared minus, so A and B, 2A and B, cosine of C. So the side and the angle always match up, and the remaining two sides and 2 times the remaining two sides. So it'd be 2A and C cosine of B, but capital B, right, for an angle. And likewise, if I use A as my point of reference, A squared, so I'm missing a B squared and a C squared, minus 2B and C cosine of my A angle. Any one of these three are considered the law of cosines, and any one of these three can be used to find any missing side. The key component here, let me move down a little bit here so you guys can see some more, and of course all that stuff disappears. So I will go forward and backwards and bring it all back. The key component is noticing this is opposite the angle, opposite the given angle, right? This is an adjacent to given angle. Okay, so in other words, you have to be given this, this, and this. Remember from geometry? It's a side angle side situation. Okay? So in that side angle side situation, you can find all the other pieces. And keep in mind, it is possible to be given 3 sides, right? A, B, and C. If I know these 3, A, B, and C, the only thing I'm missing is angle C. All right? If I'm given B and C and angle C, B and C and angle C, I'm just missing this A and that A. It becomes a little more difficult, but it's something that possibly we can handle. All right, so bottom line, if you're given 3 out of the 4 pieces, right, we have 3 sides and 1 angle, you can find the other missing piece using the law of cosines. I hope you enjoyed the presentation. I'll have some examples to follow.